So today we are going to discuss about compensating networks. So what is the necessary of this compensating network? So in order to obtain the desired performance of the system, we use this compensating networks. So compensating networks, they are applied to the system in the form of feed forward path gain adjustment. Compensate a unstable system and we can convert that into stable system. That is the necessary of this compensation. So compensating network is used to minimize overshoot. This compensating network increases steady state accuracy of the system. And an important point to be noted that increasing steady state accuracy brings instability to the system. Compensating networks also introduce poles and zeros in the system, thereby causing the change in the transfer function of the system. So due to this, performance specification of the system can be changed. Okay, so compensation networks are required and necessary. Phase lead compensation. A system which has one pole and one dominating zero. Dominating zero means that zero should be closer to the origin than all over zeros, right? So this is known as lead compensating network. So if you want to add a dominating zero for the compensation in control system, then we can select this lead compensating network. So what is the basic requirement of this? So the basic requirement is that all poles and zeros of the transfer function that should lies in negative real axis, right? This is the basic requirement. So you can go through the diagram. Parallel capacitance and resistance, that is in series with the resistance. So if you apply KVL, then you will get this transfer function which we already solved in the previous videos, how to find the transfer function for the electrical circuit, right? So the above network that can be visualized as an amplifier with a gain of 1 by alpha, right? So let us draw pole and zero plot of the transfer function. So this is imaginary part, positive imaginary, negative imaginary, positive real, negative real part. So this is negative S plane, positive S plane. So zero pole, as we discussed, zero will be dominating. So zero will be nearer to the origin, right? So you can see here minus 1 by t, that is nearer to the origin as compared with this pole minus 1 by alpha t, right? So thus we can say that lead compensating zero is more dominating than the pole, and because of this we introduce positive phase angle to the system when connected in series. So what is the effect of this phase lead compensating? So phase margin increases, so velocity constant kV increases, the slope of magnitude plot reduces at the gain crossover frequency, then response becomes faster. So these are the effects. Then advantages: due to the presence of phase lead network, the speed of the system increases because it shifts the gain crossover frequency to a higher value, right? So second point, due to the presence of phase lead compensation, maximum overshoot of the system decreases. This is one of the advantage. So disadvantages, one disadvantage is there, that is steady state error is not improved by this lead compensating network. So next is phase lag compensation. A system which has one zero and one dominating pole, that is called as phase lag compensation, and the basic requirement of this phase lag compensating network is that all poles and zeros of the transfer function of the network that should lie in negative real axis. Okay, so that is the basic requirement, and you can see the diagram. Resistance here, resistance and capacitance that are series with this R1, right? So if you find the transfer function, then you will get this transfer function. So here it provides high frequency gain of 1 by beta. So by drawing imaginary, this is real part. Here you can see pole is nearer to the origin as compared with 0, right? So we can say lag compensation. In lag compensation, pole is more dominating than the 0. Because of this, lag network introduce negative phase angle to the system when connected in series. So what are the advantages that we are going to see in the next slide? So advantages: phase lag compensation allows low frequency and high frequency which can be attenuated in case of lag compensation. Due to the presence of phase lag compensation, the steady state accuracy will be increased. These are the advantages, and one disadvantage is there, that is speed of the system decreases due to negative phase angle of the system. So speed of the system will be reduced. So next is phase lag lead compensation, that is combination of this lag and lead compensation. Why we are cascaded the both? That is, single lag or lead compensation may not satisfy design specification. For an unstable, uncompensated system, lead compensation, it provides fast response but does not provide enough phase margin, whereas lag compensation stabilizes the system but does not provide enough bandwidth. So we need to multiply compensator in cascade, as you can see here, right? Combination of lead lag. So if you find the transfer function of this electrical circuit, then you will get this transfer function G of S, that is lag lead. So if you draw the diagram, so minus 1 by T, right, is far to the origin, then minus 1 by Bt, right? Minus T is far, right? So thus we can say that lag lead compensation, in that pole is more dominating than the 0, and because of this, lag lead network may introduce positive phase angle to the system when connected in series. So what are the advantages of phase lag lead compensation? So due to the presence of phase lag lead compensation, speed of the system increases because it shifts gain crossover frequency. It shifts gain crossover frequency to a higher value. Secondly, due to the presence of phase lag lead compensation network, accuracy will be improved.